All right, so yesterday we classified matter a little further and we talked about breaking matter down from just matter alone to pure substances and to mixtures. And then we looked at those two different types of mixtures. And sometimes mixtures can be a little bit difficult to classify as heterogeneous or homogeneous. And an easy way to classify them is based on their size of the particles that make them up. And we're going to talk about this with a few examples to help it make a little more sense. But when we're talking about this, we're talking about three different things. So we have solutions, we have suspensions, and we have colloids. All right, we're going to talk about these three types of mixtures that can sometimes be a little more difficult to determine what type of mixture that they are. So we're going to start with solutions right here. So solutions are when a substance, I'm going to write solutions out again, when substances dissolve to form a homogeneous mixture. All right, and there are two parts to a solution that are mixed in together. There's so we can kind of write out almost a formula. A solution equals a solvent plus a solute. So the solvent is the substance that's doing the dissolving. That does the dissolving. And then the solute is what's actually being dissolved. All right, so a good way to think about this in an example I like to look at is Kool-Aid. All right, so in Kool-Aid, Kool-Aid is a solution. All right, and the two parts of that is the solvent, which is water. Right? Water is also called known as the universal solvent. Most things are dissolvable by it if they're dissolvable, they're soluble by water. Plus, so we have Kool-Aid, which is our solution, water, which is our solvent, and then the actual powder, right? That's the sugar and the flavoring and the dye, all those things. That is my solute. It is what is dissolved into the water to get my solution of Kool-Aid. All right, so that is a solution. Now we're going to talk about a suspension. All right, so a suspension is a heterogeneous mixture. That separates into layers over time. All right, so a good rule of thumb for a suspension is if something says to shake it up well, to be able to mix these layers together after they've settled, then it's most likely going to be a suspension. So a good example of that would be salad dressing, right? Or if we just simplify that, oil and vinegar. that would be a suspension, where we actually have particles kind of hanging out over top of each other, and that's mainly because of density. But if I have to mix those up and they settle out into nice layers, right, in a tube, and I have kind of a layer here and maybe a thicker, darker layer and different layers in my tube, and it says shake well, I know it's probably a suspension. And my last one is colloids. All right, and they contain some particles that are intermediate size between the small particles in a solution and the larger particles in a suspension. So they're kind of a combo of both. So contain some particles that are intermediate, mid-size between the small particles in a solution. Right, so think about my Kool-Aid, right? I can't really pick out, if I mix it very well, I can't pick out those powdered, dissolved particles into that water. It becomes a solution. And then my suspension, right after that settles, are very large particles that I can see and differentiate in those layers. So here we have a combination of the two, contain some particles that are mid-size between those particles in my solution up here, and the large particles in a suspension. All right, so a good example of colloids would be fog, right? We can actually see particles kind of hanging out. If you've ever looked out, if your mom or dad puts their lights on in the car, those beams, you can see, right, those particles in suspension, but you know there are air particles, small particles, that solution of air, right, that you can't see, that are fully mixed, that solution, and then those hanging suspension, those larger particles, right, of dust and whatever else that you see. Also, mayonnaise can be a good example, too, of a colloid, where we have these different particles kind of hanging out in suspension. And that's it. That's for mixtures. So here's breaking down mixtures a little further when we can't differentiate. We have these three types: solutions, suspensions, and colloids. We have our homogeneous and our two heterogeneous mixtures, suspensions and colloids, where we can really differentiate and pick out those particles versus them all being mixed together. Right, and remember that mixtures can be physically separated. All right, so we're going to talk about how we can do this later on, but I can physically take these examples apart and do this in a physical way where I'm not altering its chemical composition in any way, shape, or form.